The next part is recurrence relations. Now you've already seen recurrence relations in the first part, but now we start to work with it mathematically with using symbols. So a recurrence relation is a mathematical rule that we can use to generate a sequence, and it has two parts. We have a starting point and also a rule. So for example, in words, a recursion rule that can be used to generate the sequence 10, 15, and 20 can be written as follows. So we're starting with 10, and to obtain the next term, we're adding 5 to the current term, and we repeat the process. So our initial value was 10, and then we're adding 5 to that to give us 15, and then 5 to that to give us 20, so on and so forth, to generate the sequence 10, 15, 20, 25, etc. So a more compact way of communicating this information is to translate the rule into symbolic form. So we do this by defining a subscripted variable. Here we use the variable vn. So we're choosing to use vn as our defining subscripted variable. But the v can be replaced by an a if you want, so you can have an, you can have tn, whatever you like, but we'll just, for our purposes, we'll start at vn to keep it simple. And we're letting vn be the term in the sequence after n number of iterations. So each time we apply the rule, it is called an iteration. So using this definition, we can now translate our rule written into words into a mathematical rule. So our starting value, number of iterations for our starting value, is 0. So our initial value, Vn, we're substituting that as V0, and V0 is equal to 10. So the rule for generating the next sequence would be V of n plus 1 equals Vn plus 5. So we're starting at 10, and this is the next one. So that was VO, wasn't it? See that? 0 plus 1 gives me 1 for V1, so that's our next one. V1, Vn, which was V0, was 10, and then plus 5 gives me V1 is now equal to 15. And then we start to continue that for the next one and the next one. So recurrence relation has two parts: the starting value plus a rule. That's our starting value, and that's our rule. So if I had to go on to v of 2, for example, I wanted to work out what v of 2 was, it would be v of 1 plus 5. What was v of 1? It was 15. 15 plus 5 gives me 20. So v of 2 is 20, and you know that comes from 1 plus 1 up here, which is v of 2, which gives me 20. Generating a sequence from a recurrence. Let's have a look at this example here. So now they're saying that our initial value is v of o equals 9, and this is our rule. V of n plus 1 equals v of n minus 4. So we're taking the first term and we're subtracting 4 each time. So initial starting value is v of o equals 9. So we write that, which is right there. Now if I had to find v of 1, well, it was our initial value, v of 1, v of o, which was 9. 9 minus 4 gives me 5. Fairly straightforward. Then the next one would be 5 minus 4, giving us 1 for v of 2. There's v of 3 there, and v of 4. It's fairly straightforward. It's just following, getting it into that nice rule. And then that is our sequence generated from using that example. How do we do this on the calculator? So let's have a look at doing this on the graphics calculator. So to do this example on the graphics calculator, you just type 300, enter, then you tell the calculator to multiply it by 0.5 and then subtract 9. So you can see it does. So you got 300 there. ANS means 300 times 0.5 minus 9, and press enter, and then you just keep pressing enter all the way through, and it will generate that sequence for you. Fairly straightforward. Now you can all do exercise 8B, all questions.